Hello guys, welcome back to DSA playlist by 2am Coder. In today's video we are going to talk about big O notation, which is one of the widely used concept in data structure and algorithm, but still most of the people don't aware about this concept. But in this video we will dive into the big O notation and we will try to understand everything step by step. So without further ado, let's get started. So guys, when you talk about big O notation, there is first thing comes in the mind, that is what is big O stands for. Big O is nothing but order, and when you say big O notation, that directly means is order of complexity. So you might have seen this kind of diagram somewhere in internet. So this diagram is nothing but big O notation diagram, where x-axis represent the elements. So elements is nothing but the size of the input data. Let's suppose if your input data structure is array, so array size represent the x-axis and y-axis represent the operation. So operation is nothing but number of execution, or you can say how many time if there is any loop and how many time that loop is executing, number of iteration. So all those terms is equal to the operation. So if you have an array and you are doing some operation in that array, how many time that loop is executing or how many iteration it is going through to perform some algorithm. So that is nothing but complexity, and when you define that complexity, it's nothing but order of complexity, which is big O notation. So with that, let's come to our first point, which says it is a way to analyze the complexity of the program. So as I said, you may have loop or you may have some kind of data structure as input. You will apply some algorithm. So to analyze the complexity of your algorithm, big O notation is the way, which also depends on your input data size. So that will take you to our point 2, which says on changing the input data size, the complexity of the program may vary. So let's suppose if you are printing number from 1 to 10, and if you are using loop for that, it will execute 10 times, right? Because that loop will iterate through each element from 1 to 10. And let's suppose if you change the input array from 0 to 10, let's say to 0 to 100, so now your loop will iterate from 0 to 100 times. So you can say when you change the input data size, your complexity will also increase. So big O notation is nothing but order of complexity, which is also indicated with O in bracket complexity, and complexity also depends upon your input data size. We will try to understand each notation represented here in the graph one by one, but before going to that, let's try to understand how many types of big O notations are there and how many type of complexity we analyze of any algorithm. So guys, big O notation have two types. So basically we are going to analyze the program in two ways. So one is time complexity and one is space complexity. So time complexity is nothing but a way to analyze how much time the algorithm will take to execute. If you are printing number from 0 to 10, it will take some time, and if you are printing number from 0 to 100, so definitely it will going to take more time than printing 0 to 1, right? So you can say the time complexity of printing 0 to 100 will be more than printing 0 to 1. So here is the time complexity, and space complexity of the algorithm is a way to check how much space or how much memory particular program is taking to execute. If you are initializing any new variable and if you are storing some data in that, definitely it will going to take some space in the memory, right? So that we are going to define with space complexity. So for both of them we use big O notation, and you can see here we have mentioned big O of 1, big O of log n, big O of n, big O of n log n, and here big O of n square. So these are nothing but the big O notation which defines the complexity of the program, where big O of 1 is the constant complexity and it is in the x-axis, and why it is in the x-axis that we will see when we talk about this particular annotation. And so guys, you can see there are other big O notation as well, like O of log n, O of n, and O of n log n, and O of n square. These are placed in increasing order of their complexity respectively, whereas order of n square is the most time taking algorithm. Order of n square is the worst complexity. If any algorithm is taking order of n square time, that means it's a worst time complexity. So we will try to see each notation one by one. Just stay tuned for that.